Good afternoon to everyone. Welcome to the series of sharing session on research in physics. I'm Muhammad Faris bin Zulkifli, the moderator of today's program. I'm very pleased to see you here and welcome all of you to this sharing session. Okay. Today you'll be hearing a presentation from Dr. Eza Shuhada Sazali, leader for Advanced Optical Material Research Group. Okay. She is one of the physics lecturer in the Department of Physics, Faculty of Science, University of Indonesia. A few background about her. She obtained her Bachelor of Degree in Material Physics from University of Indonesia in 2010 and a Master in Physics from also University of Indonesia in 2012. Okay. In 2015, she completed her PhD in Physics at University of Indonesia. So, how are you today, Dr. Eza?
I'm good. Thank you for inviting me for today's session. How are you?
It's a pleasure to have you in our sharing session today. Okay. Before we start our topic about research group, okay. First of all, I would like to ask you, Dr. Eza, since when you interested in doing research, either while you were studying for a master or PhD, or when you were studying on undergraduate student, and what motivates you to be a researcher?
Okay, actually all of you will doing your final year project, right? At the end of the semester, final two semester of your degree. So I did my FYP 2010. So I'm working on thin film. So under materials lah, thin film research fabrication. Then I continue my master. I'm working on glass. So I think starting from final year project, I started to see how actually the basic on the research. Okay, because research is something that we are working on. Uh, what is actually you want to do? What overgap you want to overcome? What is the new things? Yeah, because research is something we find or we learn new things, right, and new experience. So I think I start focus my research, of course, during my master. Okay, I'm doing the glass amorphous, and also I did my PhD as well on glass lah. So we increase the novelty. Yeah, so I started focus on my research during my master. And then, sorry, your next question is what motivates me?
Yeah.
Is
What
it?
motivates you to be a researcher?
Because research is interesting, of course, right? Because we discover new knowledge, new idea, and how actually you want to work out with something that you never know. And also, research basically in master, right? You will apply all, I think almost half of the information that you gain from degree. Since last time my degree was material physics. During my time, we have 4 programs. Uh, Physics in materials, physics in nuclear, and physics in instrumentation and also optic. Yeah, okay. So I'm from physics in material. So I'm focusing more on material. So what motivates me? Because I use the information, the knowledge that I gain from the solid state physics, and then I apply during my research work. So yeah, that's what motivates me. And also actually, last time during my degree, I was a very active student. I joined many outdoor programs. I joined secretary SRM, UTM. Okay, from degree until PhD, I joined SRM. So I'm quite active, but in terms of academic, maybe because sometimes I think it's not balanced for me lah last time. So I'm quite struggle with the time management. So but Alhamdulillah, okay. I finished my degree on time as well. But that is actually what motivates me during my master as well. I want to focus more on the academic parts. Yeah, so.
Thank you, Dr. Eza, for your answer. Okay. Now, uh, we will move to our main topic for today's program. What is research group? Okay, so please welcome Dr. Eza Shuhada Sazali, who will be speaking to us on what is her research group is all about. As we know, Dr. Eza is for Advanced Optical Material Research Group. Okay, so please welcome Dr. Eza.
Okay. Thank you, Faris. Uh, Thank you everyone. Yeah, for joining today's talk. I will share my slide. Okay. Okay, you guys can see my slide, right? Okay, hi everyone. I'm Eza. Okay, I'm from Physics Department, as mentioned by Faris. So I am in materials panel. Okay, panel academic is materials, and also research group is material. So from Advanced Optical Material Research Group, and we have Dr. Salwa also. We are in the same research group. Okay, working on the materials. So this is my agenda for today's presentation. What is the motivation for this particular research group? Why do we need, you said just now, what is the motivation? So specifically in research, okay, this is the motivation that I will present to you. What is the highlights of this particular research group? Research Alliance in UTM, okay. A bit information on our group, research fact and figures, student activities, and also our blockbuster is the metamaterials. Okay, so one of it is because we want to fabricate, okay, the low cost and efficient optical materials specifically, which is mostly we are working on glass and ceramic. We also have thin film, okay, and polymer also in our groups. Which these particular materials, okay, the applications might be for laser, sensor, solar cells, self cleaning, and also several other applications. It depends on the demand. Okay. And the preparation as well, okay, the motivation is we want to get easy and also eco-friendly methods, and subsequent characterization are mandatory to achieve such goals, okay. And a deeper investigation into the structure of disordered materials, you will learn later in the solid state physics. We have three types of solid materials. Okay, you have crystal, polycrystalline, and also amorphous. So crystal is like most perfect structure of materials, but the amorphous or glass is contra of the crystal. It's disordered materials. So how do we want to explain this? How do we want to determine the structure of materials that you want to use? Okay, we can use by the computational method as well, using simulation to find the academic and molecular origin of the microscopy of the property. So there are so many properties in research. Okay, later on you will continue on your final year project. So there are many properties: structural properties, optical, mechanical, electrical. Okay, so those properties have their own ways of characterization and the expectation of that. And also, this particular research is not only generating new knowledge, okay, of novel materials, but will contribute to the national economy, industry, and society, okay, through the grants that we gain, okay, the application, what can we give back to the community as well, okay. Okay, the highlights of our research group, okay, again, the production of the low cost, the fabrication of the low cost and efficient functional materials for advanced optical applications. And we can tailor the various properties by activation, sensitization, doping, embedment. We control the composition of the materials, okay, because we want to produce the efficient functional materials. So we play around with the rare earth, with a nanoparticle. When you heard about what is nanoparticle, is anything lesser than 100 nanometer. So we are working on that. And then we can predict optimum composition, okay, for the materials of properties of engineering materials with selected properties, okay, and development of freestanding, okay, no phase separation biopolymer film, okay, Dr. Salwa working on the thin film as well, okay, and also we are working on the biopolymer electrolyte, okay, in rechargeable photonic cell applications, okay, and of course generating new knowledge on novel materials for national benefits. All of this material will contribute to the society, nation, okay, it depends on the applications what we want to do. And we want to create skilled human resources through research training and practices. basically when you continue on full master research student, so you have like 3 or 4 semester, okay, to complete your master. And for PhD, average is like 3 to 4 years. So during that particular time, okay, under research training with the supervisor, with the colleagues of research group, okay, the environment, the experience, okay. So we try to create a skill researcher, okay, and experienced researcher. Okay, research alliance, okay, in UTM, okay, there are so many research group. We have 7 faculties, right, under the synergy. So in faculty science, we have 4 departments, physics, bioscience, chemistry, and also mathematics, and we have other 6 faculties. And we have so many research group, even in faculty science itself, we have like 15 research group, okay, and plus the rest in UTM. So all of these research group are mapped into 5 research alliance in UTM. We have frontier materials, resource sustainability, health and wellness, innovative engineering, and smart digital community. So AOMRG is mapped under frontier materials. So we are actually MD group, MD research group, which is multidisciplinary. So we pop under frontier materials research alliance. Okay. Okay, a little bit introduction, okay, for AOMRG members, okay. So I'm the group leader, and also we have one adjunct professor, Prof. Saha. Okay, last time he teach me during my degree as well, and then he was my supervisor for master and also PhD research. And also we have Prof. Dr. Sip Krishna Goshal. Okay, Dr. Sip also working closely in the optical materials. He was my course supervisor last time. And then we have Dr. Kaize. Where is the... Sorry, okay. Okay, we have Dr. Kaize from SKT, okay, School of Chemical Engineering, Energy. And then we also have Dr. Rozik, Cik Rozik, he's from Department of Chemistry. Also, Dr. Rohul is from Chemistry Department. And we have Dr. Rahman Tamuri. I'm sure you know some of them, right? Dr. Roslinda, Dr. Hidayah, Dr. Faizani, Dr. Rosnita, Dr. Nohafiza, Dr. Salwa, Madam Masliati, all are from Dr. Ali Reza from Department of Physics. We also have Dr. Jasman from SKT. Also, we have 2 research officers, Mr. Wan Hairul Anwar and also Mr. Muhammad Nabil. So these are our group. And then our research core area, okay, we are working on glass synthesis and characterizations, crystal growth characterizations, solid state laser materials, nanomaterials, analysis using analytical techniques, okay, semiconductor nanostructure, non-crystalline solid ceramics, thin film, perovskite-based thin film solar cell, quantum dots, okay, surface science and chemistry, synchrotron spectroscopy, liquid crystal, magnetic resonance spectroscopy, and photocatalysis. So we are not only focusing on one materials, anything that material related. Okay, so these are our core areas. So we have this is our collaborative partner. Okay, so Dr. Faiz and Prof. Rahim also graduated from Warwick University. They did their PhD last time UK. Also, I work closely with UITM. We work closely with UITM. Also, we are also some of the members are the committee members of MES, Malaysian Solid State Science and Technology UTM chapter. So we are part of it. We also working together with University Negeri Semarang, Indonesia, Northgate University, India, UTHM, and then GJAS, Guru Jambeshwar University, India. Also, we got also some collaboration with industry, OIBJC. Okay, this one is actually glass industry. Also, we have the Science Technology Facility Council, and also here, this one, Universitas Telkom Universitas. Okay. Okay. So some of the performance, okay, as I can say, performance of facts and figures of AOMRG for 2021. So basically, a research group is basically a group of researchers, okay, that might it does not necessarily 100% similar project, but as you can see, it's the same core research area. It's likely equal to. So we are working together, okay, to to increase the performance in terms of grant, because with grant, okay, you can have a students, master or PhD students, and then we are working with the research, and then we publish in the journals and we share to the world the findings, right? So we need grants and also publications. So some of it is alhamdulillah, okay, by 2021 we managed to get like 1.7 million for internal grant meaning university grant, and also outside, okay, outside can be national or international grant, 1.134 alhamdulillah. Okay, so basically in LMRG we are working together, okay, maybe for the as I said, for the research, publications, networking, all of this we did together. Okay. So we have current active students like 20 students, master and also PhD, and also we have some for dissertation master. Dissertation meaning you continue master but mid small. So 1 year for lectures, you join the lectures, and one semester for research. So this one we call it dissertation. So some of them you can choose the supervisor, and one semester, can you imagine in one semester what can you accomplish, right? So this is by guidance of your supervisor. So this is some of we have a very large group, okay. So some of the students started here from degree to PhD like me, and some of them maybe started in LMRG from master, and some of them from PhD. So we have very large group here, and sometimes we did the makan-makan, the event to celebrate maybe to celebrate the performance, or maybe retirement, okay, celebration, birthday celebration. So yeah, and we also have, you can see quite a numbers of international students previously. So until now, they are our alumni. So we still collaborate in terms of publications and research. These are some of the activities that we done 2022 and 2021. So we did the how to write grant, how to write edited books, how to write high impact articles, okay, and some online global classroom. Also, if you can see, we also did co-organize some program with other research group. Okay, we work inter research group, inter departments, inter faculty. So that is how synergy works. So some of the figures, some of the poster from the programs. Okay. Also like this, we also have our partners from UiTM join the program. Okay, and we did it online and also face to face. So this is for 2022. Okay. Okay, so the main project for this group is the meta materials. Okay, what is the meta material? It's the functionally advanced materials. So synthesized by combining elements shaped from composite including metal, semiconductor, polymers, plastic. Some of you might be wonder what is actually difference in metal, semiconductor. You will learn later. Okay, this is your first year. You will learn in second, third, and fourth year what is actually semiconductor, what is actually metal, what is the difference between amorphous and crystal. So metal, you have one valence electron. Okay, so why is it one valence electron? Because it is free electron, it's free to move. So that's why the conductivity is high compared to others, compared to the insulator, for example. So all of these things you will apply in your research. So it's very interesting. And also the shape is very important. Can you imagine the shape of your, if you are working on the growing of the nanocrystal, for example, the shape, the morphology, the size of the nanoparticles, okay, the orientation all affect the structural properties, which affect the efficiency of the applications. And combining the knowledge of electricity, magnetism, solid state physics, material science, all you learn, okay, you will learn in the degrees. So this is an example of lasing action of glass, okay. Can you imagine if you have metallic nanoparticle in your glass, in your amorphous? So without nanoparticle, you must understand what is the bonding, okay, bonding of the materials inside the materials. And then what happens if we put the material nanoparticle, you will have a dipole, okay, dipole, which is the accumulation of positive and negative charge at one side. And then once they got resonance, everything will be enhanced. So that is the one that we studied. So we explain theoretically, fundamentally, and compare with the experimental data. So this is how we did. Okay, and then this is some of the one of TM image that shows the morphology of nanoparticle in host. Okay, and also this is some of it that mechanical degradation using the SBF, stimulated body fluid, okay, in vitro. So some of us are working on the bioglass, which we are working on the scaffold, amorphous scaffold, to replace the bone fracture. Okay, so how actually we went from the glass, okay, and then we combine with the polymer, and then we make it a scaffold, 3D scaffold, to replace the bone fracture. And how do we want to explain? Is it um, what we call it compatible with our body? So we need to use this SBF test, for example. Okay, and then we can see what is the ion release from there. So that is the example, and this is also example of self-cleaning glass. Okay, how actually our glass, okay, is it hydrophobic or hygroscopic? And can you imagine the car, okay, the glass for car, right? So if it's raining or you have dust, so how actually the angle and etc. So these are some of the applications, okay, of the materials. So I shared a bit on some of from researcher profile. Okay, this is from Dr. Rosnita. So Dr. Rosnita working on sorry, how do I? Okay, Dr. Rosnita working on solid oxide full cells, SOFC. This is electrochemical. Okay, so she's working on the problem statement. Okay, what is problem statement? Later you will learn. Problem statement is actually why you need to do the research. So what is the research gap that we want to overcome? What is the improvement that we need to do? So in this particular research, she's working on the high temperatures led to cell degradation. Okay. So what is the possible solution? So she proposed on this particular material. So that is what we do with materials, okay, to overcome the problems on the previous study. Okay, so working on the fabrication of SOFC, okay, by sputtering technique, sol gel dip, thermal evaporation, CVD technique. Okay, and as I said just now, we characterize all the properties, maybe some of it. So it depends on the application, like this structural, morphology, and electrical using SRD. So you will learn also SRD in solid state physics later. How actually you want to determine the material only by you bombard with X-ray, okay, X-ray diffraction, and the diffracted pattern, we can determine the structure of material, for example. Okay, so the potential of this particular SOFC thin film for full cell car, portable devices, and others. So this is Dr. Rosnita works. And next we go to Dr. Faizani. Dr. Faizani working on experimental, both experimental and also simulations. Okay, he's very expert in structural, okay, everything that you cannot see in your own eyes, right? So he can get this one using the simulation as well. So he's working now on the boro-Germanic glasses, okay, and also amorphous pharmaceutical. How our medicine now, okay, if we make it amorphous, some of it is crystalline structure. So he's working on this. The motivation is a deeper investigation into the structure of amorphous material by experimental and computational method to find the atomic and molecular origins of macroscopic properties. So some of the theme is atomic and molecular physics of amorphous material. So it's working on with Raman scattering, NMR, FTIR, okay, material formulations, molecular dynamics, computational chemistry, okay, bone valence assessment. If you want to know in detail on his research, you can contact him. Okay. Next, we have Dr. Hidayah. Okay, Dr. Hidayah working on biopolymer. So the types of material you can see biopolymer, which is cellulose-based derivative, and also ionic dopant, ammonium salt. So she's working on the let's see this one. Okay. Yeah. So the novelty, okay, the novelty is the usage of novel green material of semiconductor electrolyte. So talking about bio, meaning it must be compatible okay, bio with the body. So this is sort of like new innovation of eco-friendly rechargeable cell based cellulose solid biopolymer. It's very interesting here. Then this is some of the characterization. So mostly people who are working with material, they're working on the characterization and analysis as well, because we need to determine the efficiency, okay, the characteristic of our material. Okay. Then next is Dr. Nur Hafiza. Okay, Dr. Nur Hafiza. She's working with on glass and bioglass, ceramic and also crystal. And her research area, okay, mid safe infrared laser purpose, okay, the application for laser, self-cleaning purpose, as I mentioned just now, bone regeneration as well. So this is all the characterization she did and analyzed. So this is her expertise. And as I said just now, the when we bombard the material and particle, you can see when they reach the resonance frequency, how do we want to explain fundamentally, okay, how actually they can increase the absorption emission, for example, right? So this is what Dr. Nafiza did. And then we have here Dr. Salwa. Okay, so Dr. Salwa working on the green inspired materials towards sustainability of nature, also green materials, okay, biomaterial. So she's working on the synthesis nanomaterial to remove dye waste from aqua solution, and also preparation polymer electrode for batteries and solar cell. Okay, and if you can see in detail here, okay, in terms of the synthesization, okay, using the green approach, nanosynthesis zinc oxide using by green approach, okay, nanoflower like zinc oxide. So this is very interesting. You can ask Dr. Salwa later what is actually nanoflower zinc oxide, how actually it looks like in the microscopy, right? And also the specific analysis, okay, to confirm on this, and also the applications for adsorption and photocatalysis, okay. And second, preparation polymer and solar cell, okay. So green polymer electrolyte is quite similar with Dr. Daya, they're working together, and also the characterization, also the applications for, of course, for solar cell, and also they compare the real and simulation performance. So Dr. Salwa, Dr. Hidayah, Dr. Hafiz are also working on simulation, both simulation and also experimental. And last one is my research profile. So I'm working on 4 core area, glass synthesis and characterizations, mesoporous borosilicate bioactive glass scaffold that I mentioned just now, to replace the bone fracture, okay, and nanomaterials analysis. Okay, I also embed the nanoparticles inside my sample to see the enhancement of the properties. And organic and organic hybrid glasses. I also did the sensing parameter using the cinnamon. So we do the hybrid research, combining the amorphous in organic and also inorganic hybrid. So how actually the cinnamon helps to improve the properties. So this is also some of the calculation that I did. And just to share you, okay, the TM image that this one is actually I get from my PhD. So I using the gold nanoparticle. So I do the heat treatment, which is the same glass. Okay, we give heat treated the glass with different duration, different time duration. You can see the size is different. Okay, the size, the average size also change for each sample, even though it is the same sample, just we put in different heat temperature, heat duration. So this is how you want to explain the fundamentally. Okay, maybe because of the crystal, the growth, the coalescence, okay, the ripening. So we need to explain on this lah. And also the bioactive material as well. As I mentioned just now, the mesoporous material. Okay, so our focus study is to fabricate the bioglass, okay, bioglass scaffold, which to get the higher deposition rate of HCl layer. Hydroxy carbonate apatite ni, this is the one that when you touch your bone is keras, right? The hard surface is actually the HA layer. So how actually we want to fabricate a very good materials that can encourage, okay, the deposition, the HA layer, okay, the formation of HA layer. So that is example lah. So yeah, that's all from me for AMRG. Thank you so much.
Okay. Thank you very much, Dr. Ezra, for giving such an informative and interesting presentation. It is new thing to me, and I bet everyone feels the same with me. Okay. Now we come to the Q&A session. Okay. If the participant want to ask question to Dr. Eza, you can type in the chat box. Okay. Okay. If we interested to be a researcher kan, so what we need to do, is there any special procedure, or we just go to the research group, we join and we do the research?
Are you talking about the master and PhD?
Yeah.
Yeah, okay. Yeah, actually you can simply reach to any lecturer, any supervisor, okay, with their own expertise that you're interested to continue your master or PhD. So you meet them, then you can discuss on what actually you want to do. Sometimes the supervisor will give you the title. Sometimes because we get the grant and then we find the students, so the student need to do likely equal the topics of the grant proposed, right? But sometimes the supervisor give student to choose their title, but in her or his expertise. So once you agree on what actually the field or the title that you want to do, then you can simply register. Okay, register in SPS link. I think Sawa maybe later can share the link, and you need to submit a simple proposal. So of course your supervisor will guide you how to write a good proposal, and then you register, then you can continue. So basically research is will start at first semester. Is usually we call it literature review. Okay, you review the previous research, okay, because we want to find the basis, the background of your research. For example, okay, during my PhD, I fabricate tellurium glass, okay, but I embed nanoparticle, right, as I said just now. But why should I put nanoparticle? Because previously, when we study, without nanoparticle, okay, the absorption or cross emission section is very small. So how we want to increase? Maybe by embedding the nanoparticle, right? So this is how you will find in the first semester, okay, to get the problem statement. So that is the process lah for research. And then second semester, you will do your first assessment to present in the panel. So is it approved for master or PhD level? Then you continue, proceed your experimental or simulation, then submit. So very simple. So you can get to know the researchers. So in physics, we have 4 panels: materials, optics, instrumentation, also nuclear, which from all this panel, also we have particular research group under this panel. And then, but some of them also they got cross panel. Maybe some of them is from others panel, but they join other research group. So it's okay because you know the expertise might be different. Okay, in academics also research. So we have synergy there. Okay, then you can find what is the field that you're interested to do, because sometimes if you love working in the with the electrical, for example, maybe you can go to instrumentation, right? So during degree time you will observe, or you will know yourself, okay, what is actually the field that you want to go next for the research. Paris, I pass to you.
Doctor, there's a question from Hafiz asking about how do we determine what kind of research is suited for us, or do we just join for the knowledge?
Because you need to identify first before you start, because once you registered, you will take like 2 years, 1.5 years or 2 years for master, 3 years for PhD, right? So better you need to know what you are interested, because maybe now it's too early because this is first year. By time, okay, you will learn so many subjects, okay, because the subject also we have general subject for our student, and also we have quite specific subject on the panels, okay. But inshallah all is everything is interesting, but you know which one that you what we say interested more, or you like more. I don't know what is the correct term, but you will know. For example, if you like optic, you like working on the laser, on the fiber. Sometimes you see movie, or you find somewhere in YouTube, oh, you say, wow, it's, you know, the fiber fabrication is very interesting. So you can simply search, okay? And also this sharing session, you will know later, I think Optic, for example, they will explain how actually they fabricate and etc. So if you're interested, you can simply go to the research group, the supervisor. So you will know yourself lah. By time inshallah. By time inshallah you will know yourself. Before the 3 years, within this upcoming 3 years, inshallah you will know which field that you want to continue your research.
Okay, Doctor. Okay. Next question. Okay. What's your advice to us, the new student, undergraduate student, who want to be a researcher one day?
Okay, honestly, it's not easy to be a researcher, right? Because it requires patience. Okay, you need to be very hardworking, as I can say, and then time management. Okay, so um, ask yourself, okay, are you ready for it? But it's okay because during the final year project, you will experience your very first research, even though that is at the FIP level, okay, but you will learn the experience the basic how to make a good proposal, okay, and then your supervisor will guide you how actually to do the research. So to be a good researcher is you must be able to accept, okay, to discuss a new idea. Don't be too defensive, don't be too you need to have your stand as well, right? Because a researcher, because we need to defend our research as well, but make sure our research also is valid, and also what is the benefit you can give to the world lah. Okay, as I can say, to the world, because the publication help others. When we publish, people see our paper, okay, and then they refer to do more research. So that is how we engage. So a good researcher is with full of patience, uh, very hardworking, okay, and also time management lah, as I say. You can open mic anyone if you want to ask.
Thank you for the answer. We see the chat box. There's no question here.
Why I did not see anything in the chat box? Oh, you have another chat box. You can open on the mic so we can interact. Anyone who want to ask?
Is there anyone?
It's okay. This is just a very relaxing session. Just sharing session.
I think there's no question. Okay.
Okay.
Okay. We finally come to the end part of our program. Thank you very much, Dr. Izzah Shuhada Sazali, for this interesting topic. It is very useful to us, especially for you one student like me. Okay. So, on behalf of the introduction to physics subject, I would like to invite Dr. Salwa to conclude the program. Dr. Salwa.
Okay, Assalamualaikum and thank you everyone. And also thank you Dr. Izzah for joining us today's session. So basically I hope everyone can get lots of points from AOMRG, right? So you are free to ask anything about AOMRG with Dr. Izzah. Okay, you can email her or contact her personal. And also for my section, okay, if you want to know more about AOMRG also, I will share with all of you lah. Okay, and I hope all the students can get some point, right, from our first session on 10th of January from Professor Hairul, from Dr. Shazwan, and also from today's session. And with this, I would like to say thank you to everyone, especially our speaker and also our coordinator, the Ain Hussein, and to all the students who attend for today's session. And not to forget for some of the staff, academic staff who joined us today. Thank you so much.
Thank you, Dr. Salwa. We would like to present our speaker today, Dr. Izzah Shuhada Sazali, with a certificate for joining us today.
Thank you.
Okay. Okay, next we are going to have a photo session. So everyone can open the camera so that we can the photo together. Okay. You guys can open the camera.
Okay, ready? Hafiz pula. Siapa? Hazim? Sharekan ni. Okay. Alright. Okay, for the first page. Alright. Okay, everyone ready? Okay, 1, 2, smile. Okay. Okay, for a second. Okay, again. Freestyle. 1, 2, 3. Okay, thank you.
Okay, by this we will end our sharing session here. And thank you to all participants. And I hope this session will guide you for your future career, inshallah. Thank you to our speaker, Dr. Eza, and our participant, Active. Inshallah, okay, I think that's all from me. Thank you, guys. Thank you, Doctor.
Thank you, everyone. Assalamualaikum.
Thanks, Dr. Izzah.
Thank you.